Hello, Algebra. I hope you're having a great day. I'm sorry I can't be with you, but this is like the next best thing. It's like I'm here without being here. We're going to cover two different topics today. The first one is the distributive property. But before we get into that, let's just look at this problem. So up until today, you would have solved this by using PEMDAS, right? And what comes first would be P for parentheses, so we would simplify this. So we get 5 times 6, right? Which would be 30. However, maybe some of you thought of this yourself. You could have also solved it like this. You could have taken this 5 and distributed to both of those. So really what you're doing is taking 5 times 2. So what is 5 times 2? Well, that's 10. And you would also do it to the 4. So again, remember you're multiplying when you do that. So times, so 5 times 4 would be 20. So plus 20. And then if I add those together, I still end up with 30. So do you see how we still get the same answer, even though we solved it differently? So that's kind of our little segue into our lesson today. Because now what happens if we have a variable here instead of a number like we had in these two examples, right? So the process is the same, we just won't always get a number. Again, you're just going to distribute. So I'm going to take this 5 and multiply. So what's 5 times x? Well, that's 5x. And then 5 times 4 would be 20. And that's our answer. So this right here, what we just did is called the distributive property. So now, I would like you to take the foldable and glue it into your notebook. So you're going to glue it so it opens, so you can see the word distributive property. So you're going to glue on the side that's blank, okay? And then when you open up the flap, oops, hold on one second here. It should look like this. So when you open up the flap, this is what you'll see. Okay, so now we're going to try some of these examples together to practice the distributive property. So it really helps if you draw these arrows like they did here in all of their examples. It just kind of helps you to multiply to each individual term inside the parentheses. So let's just get started. So if I take negative 5 times 5x, well, 5 times negative 5 is negative 25, and don't forget the x, and then negative 5 times 7 is negative 35. And that's it. We're done. Okay. Now what's different between these two examples right here is this one only had 2 terms, and this one has 3, but the process is the exact same. So you're going to take 4 times 2x and get 8x. 4 times 3y, well 4 times 3 is 12, so 12y. And then 4 times 10 is simply 40. That's our answer. Okay. Let's try another one. 6 times 5x is 30x. 6 times negative 7 would be negative, oops, not 35, negative 42. And there we go. That's our answer. Okay, are we feeling okay? How about you pause the video right now and you try this example right here on your own. Okay, ready? Pause the video and try it. Go. Are you pulling my leg? Did you try it? I hope you tried it, because I'm going to do it right now, and don't let me spoil the fun for you. Okay, negative 2 times 2x would be negative 4x. Negative 2 times negative 3 would be positive 6y. And then negative 2 times negative 10 would be positive 20. Are we doing okay? I think we got a good feel for this? Okay, I have to erase my board here so I can scroll down. So I'm going to erase this. I guess what's nice about the video is that you can pause this at any point if you need to and copy down what the screen says. Okay, And And now our last one here, let's look on these examples over here. So do you see how before all of our examples, we had the number out front in front of our parentheses, right? But now down here, we notice our number is in the back. But just note that it doesn't matter. It's the exact same process, it's just from the back. So again, you're just going to take and multiply through each individual term. And if that confuses you, then just rewrite it with the number out front and get rid of it back here. It doesn't matter, but just know that the process is the exact same. So let's try this one together. So 3 times 5x would give me 15x. 3 times negative 7 is negative 21. Are you rocking it? Feeling good about this? I hope so. Okay, last one in our foldable here. Again, 7 times 2x is 14x. 7 times 3y would be 21y. 7 times negative 10 is negative 70. We rock. Good work, kids. Okay, so that should be it for our foldable, right? Okay, and then you should have one more handout to glue into your note, so take that moment right now to glue it in. Pause the video if you need to while I get the notebook back up here. So now we should be on the little handout that says simplifying algebraic expressions, combine like terms. So now we're kind of shifting gears into combining like terms. And what that means is that we're going to take things that look alike and add them together so our expression is more condensed and not so long like this. Okay? So what you should look for, and it helps me if you kind of like color code things. So I always start with my first term. So I have a 5x. So I'm looking for another term that has a single x like this one. So the 3 doesn't have an x, the 10 doesn't, but oh, this negative 7 does, so I'm going to go like this. So I know those are like terms. So now I'm going to take 5x minus 7x, and I'm going to get negative 2x, because I know 5 minus 7 is negative 2. Okay? And then I'm going to go to my next term that doesn't have anything underneath it. Negative 3, well, that doesn't even have a variable, so I know I'm going to combine it with something that doesn't have a variable. 10. So what's negative 3 plus 10? Well, we know that would be 7. So now, this is my final answer because I can't simplify it anymore. Because this term right here has an x, and the 7 is just a constant. They're not like terms. Okay? So like terms have to have the same variable. Okay, does that make sense? Alright, let's move on to this one. So again, I'm starting with my 5x, and I'm looking for another term that has an x. Nope, that has a y. Nope, 1 doesn't, 4y doesn't, neither does the 8. So I'm just going to drop down my 5x because it's all by chromosome. Okay, and then I'm going to move on to the next one. Minus, I'll use a different way. Oops. Minus 3y. The 1 doesn't have any y's, but this 4y, that's a y, and the 8 doesn't. Okay, so what's negative 3y plus 4y? Well, that would just be 1y. Okay, how do we feel? Are we kind of confused? I hope not. Okay, and then what am I left with? I have a 1 here, so I'm looking for another just plain variable term. Or excuse me, just plain constant, just a number. And there's an 8. So what's a 1 minus 8? Well, that's minus 7. So that is my final answer. And then you can always go back and check because each one of my terms have a different symbol or coloring by it. Yep, so I know I've used everything that I need to. Okay, so let's maybe write this. Like terms have the same variables and exponents. And we didn't have an example with a different exponent, so I'm going to make one up quick. Would you please write this in your notebook? So please write this following example in your notebook. So write this. We'll say 3x squared plus 4 minus 5y, no, we'll make that 5x, plus 7x squared. Okay, so let's see here. So again, I'm going to start with my first term. Okay, make sure you have this written down in your notes. Okay. So I have 3x squared. So now I'm looking for another term that has an x squared. Well, the 4 doesn't. The 5 has an x, but not an x squared. But if I keep going, look, this 7 has an x squared. So I know those are like terms. So 3x squared plus 7x squared would be how many x squareds? Well, 10 of them. Okay, and then I'm going to keep moving on. My 4, it doesn't have a buddy. There's no other single constants out there, so it's just by its lonesome. And then I'll check my 5. Is there another plain x term around? Nope, so it's just left as minus 5x. So again, the key to this is that your like terms have to have the same variable and exponents. Okay? I know I'm kind of moving through this fast, and it stinks that I can't see your face to know if you're understanding this or not. But again, help each other out after this. Work together. Maybe the sub will know how to do some math. I'm not really sure. But if not, again, we'll work on it on Tuesday together if we're totally lost. Okay, and then we have one more set of examples here. So now this time we're kind of combining both ideas together, the distributive property, and then we're going to combine like terms. So first we need to distribute this 7 through here. Okay? So 7 times 1 is 7. 7 times negative 9k would be negative 63k. Then I'm going to keep following my equation here, so then I have a minus. Okay, now I'm going to take 5 times 4k and get negative 20k. And then negative 5 times 7 would be negative 35, right? Okay, now from here comes the combine like terms piece. So I've already distributed, but now I need to combine like terms. So again, remember we start with the first one. Do I have any other single numbers by themselves? Well, sure I do. I have 7 and then negative 35. So what is 7 minus 35? That should be negative 28. And then remember, we move right along. I have a single k term, so negative 63k minus 20 more k's should get me negative 83k. And then in the end, we shouldn't be able to simplify this anymore, which we can't. Okay. Okay, you try this last one, so pause the video. See how it goes. Just remember, there's an imaginary one right here, so you gotta distribute that imaginary one through. So pause the video, try this one on your own. Otherwise, you're not gonna really know how to do this if you're just copying down what I write without thinking about it. Did you pause it? I bet you're doing great. Okay, here we go. Spoiler alert, answers coming. So first we're going to distribute. 10 times x is 10x. 10 times negative 2 would be negative 20. Okay, now this is that weird part. So I have a negative 1 that I need to distribute. So what's negative 1 times a positive x? Well, that'd be a negative x. And a negative 1 times a negative 4 would be a positive 4. Okay, and now again, we are going to combine like terms to simplify this expression. So 10x combines with the other x's, so 10x minus x gives me a 9x. And then remember, we move right along. Negative 20 combines with the positive 4, so what's negative 20 plus 4? That's minus 16. Okay. I realize I'm not here, and I really apologize for that. I hope this is okay. Do your best on the assignment. Be good. Help each other out. Remember, we're a team here. And like I said, if all else fails, we will figure it out on Tuesday together when I can see your faces. Have a super great long weekend, and we will see you Tuesday.